Hello, let's learn about multiple inheritance and method resolution order. So, in this session, we'll explore one of the most interesting aspects of Python's object model, multiple inheritance. We'll see how Python determines which method to call using the method resolution order or MRO and how super fits in the picture. So multiple inheritance allows a class to inherit from more than one parent. While this gives us more flexibility in structuring the classes, it also gives ambiguity. For example, when two parents define the same method, Python resolves the ambiguity using a well-defined method resolution order, ensuring predictable behavior. First, we'll understand about a single inheritance. Before diving into multiple inheritance, let's have a quickly review single inheritance. In single inheritance, a class derives from just one parent. All the attributes and the methods are directly from that one parent. So think of it as like you might have a class A and you want to create a class B, like directly kind of take some of its attributes and give it to class B. So without creating a new class or without defining a new class, we can just inherit those properties from class A and we can give it to like class B can have same those kind of same properties. So we'll just see how we can uh, define those and with an example for our understanding. So here you will see we already have a class A which is already defined and greet self like with a definition of greet self, and we have typed a like a simple state hello statement like print hello from A. And now in this case we are like defining a new class, or we are inheriting those properties from class A to class B. Okay. So here we have defined a class B and in the parenthesis we have given it like a class A. So this means that we are inheriting the properties from class A, and we are like giving a pass here. So when we type p parenthesis dot create, when we call this, it will basically this function will directly go into class A and will do whatever the function or the task it has given to the in the class A. So here we have a since we have very simple task here like print hello from A, it will just print this particular it will just perform that particular task and give us the output of it. So this is what inheritance is like single inheritance means. So type inspection. Python provides some built-in class hierarchies, inspect tools to inspect the class hierarchies and types. Like type object returns the type of the object, and is instance object class checks if an object is an instance of that class. Then we have is subclass sub like checks the class relationships, and class MRO or object class reveals the exact MRO used by Python. This is extremely useful for debugging complex inheritance structures. So let's see what is multiple inheritance. In multiple inheritance, a class can inherit it from more than one parent. Okay. So for example, here we have given like if we have already have a class A and class B, and we want, both like the both what you can say both properties of class A and class B to be inherited into class C. This is where the multiple inheritance comes into picture. So basically, it will inherit it from both the classes and give us like a final what you can say create a new class like how as per requirement. So when we call a method on class C, Python searches for its following the order defined by the MRO. This allows us to combine different behaviors from multiple sources. In single inheritance, Like we were only dependent on a single class in multiple inheritance. Since we can take more than one class, it's like we can have like different sources to get a final or create a new class of it. But since we are like getting inheriting from different classes, we need to be very careful, because we have to like avoid the conflicts, we have to name it in such a way that there's like no collisions or unintended overrides. So let's understand the method resolution order, MRO. The MRO determines the sequence in which Python searches for methods and attributes. Python uses the C3 linearization algorithm to produce a consistent and predictable order. We can read this order using class.mro. For example, if C inherited from A and B, the MRO will be typically be like how we have seen here with C, A, B, and object. Python follows this sequence every time a method lookup occurs. So next we have a function called a super. This allows us to call methods from parent classes without naming them explicitly. What's special is a super follows the MRO, not just the immediate parent. This enables cooperative multiple inheritance where each class plays its part in a larger inheritance chain without hard coding parent name. In essential in complex hierarchies, especially with frameworks that relies on cooperative behavior. So here we have something like resolving the mystery. When multiple parents define the same method, Python simply looks at the MRO and picks the first match. Then super uses the same order, moving to the next class in the MRO rather than a single parent. Understanding this explains why certain methods are called even when it seems like they shouldn't be. This mystery disappears once you understand how Python works the MRO chain. To summarize it, multiple inheritance enable powerful class hierarchies. MROs define a consistent method lookup order, avoiding ambiguity. So basically, we have seen around type inspections, which helps us explore and debug inheritance hierarchies. And since we have also seen a single inheritance, it comes in handy when we want to like inherit from that particular single class. And if for multiple inheritances, if we want input from the different sources, we can go for multiple inheritance to create a new what you can say a class for it. So this is basically for um, classes. Let's meet in the next video.